Okay, so let's start. What time I have? I have 15 minutes or 20 minutes. Okay, let's do some brief introduction of openEuler. And I'm the executive director of openEuler. So if you want to use some simple word to explain what is openEuler is, I think there are three technical labels for openEuler. The first one is the all scenarios. When we're talking about the OS is very complicated, from the cloud, server, edge, to embedded. It's a very different kind of a scenario. How to make the OS can meet different scenarios, that is the key question for the operating system developers. So here is the architecture of openEuler. What openEuler is, actually it's very simple. The define is very simple. openEuler is an OS platform that allows you OS creation from different scenarios. That means we have a package pool. The package pool is collect all of the components of operating system. And then we develop a new tool, which is called Euler Maker. Go through the Euler Maker, we can create a different kind of operating system. And all of the operating systems, they share the same kernel version, they share the same software base, and they share the same ecosystem. So if you are a chipset vendor, if you want to compatible with openEuler system, it's very simple. Just make your patch go into the repo, to go into the kernel, and then all of the system created by openEuler can meet your requirement of your chipset. And the same with application. So that is the first, I think, technical label for openEuler. That is the OS platform for all scenarios. Okay, the second technical label is, we call it diversified computing. What means diversified computing? For nowadays, in the old time, the world is ruled by just Intel or x86, but now more and more new chipset and architect get out, released. For example, we have a lot of ARM server, and we have a lot of new RISC-V chipset, and we can see some RISC-V board or chipset, or even the desktop outside in the booth. So when there are so many hardware appears, how we make one OS to meet the requirement of different chipset, that is also a problem. So nowadays, openEuler support most of the mainframe architecture. For example, the x86, ARM, RISC-V, and SW68, and Power. And also there are a special one in China, which is called Long Arc. And it covers from the server, cloud, edge, and the embedded system. So we want to make the openEuler to support most of the chipset and board in the market. So if you want to get any board, it's very easy to you to migrate or porting your openEuler on top of this chipset. So here is the list that we have support. There are over 100 kind of devices you can use. And also we have a lot of chipset vendor has participated in openEuler. For example, Intel. Intel is also the golden member of openEuler. And every year Intel will donate a lot of money to openEuler project. So that is also, we get involved the chipset vendors. And also we support over 600 card, the device card. For example, the network card, storage card, and AI card. So that is the diversified computing that openEuler has supported. And if you say, okay, if we met some new card or chipset openEuler doesn't support, what we should do? It's very easy. Just report one issue or raise the requirement to openEuler community. The community will have a special SIG, which we call it compatible SIG. We're working with the hardware vendors to make the hardware works on top of openEuler. Okay, next, the most important technical label is AI. Nowadays, AI is so hot. Every time, if we don't talk about AI, I think that the summit is not so interesting. Here is the AI, what openEuler has done. openEuler for AI, we do some two directions. One direction is to use AI to change something in operating system. So we call it AI for OS, accelerate the arrival of tomorrow's intelligent world. Here on the left, there is an example. Sorry for maybe the English translation is too small, but I do the explanation. On left, the video has shown is a performance tuning process. When we use, for example, the NGX, Apache, MySQL, or database, or other kind of database, if we want to get the best performance, you need to do a lot of tuning job, right? This is tedious and very involved a lot of expertise. Do we have idea that we can use the nature language to talk with the AI to let them help me to do the tuning job? So here we develop a tool, we call it EulerCopilot. You can use the language to talk with the AI, the tool, and the tool can do a lot of things for you. For example, if you not familiar with the shell, if you want to write some shell code, it's very difficult. For example, I want to search all of the text file under some directory, and then when I want to replace some of the string inside of the file, okay, you can give the sentence to EulerCopilot, and the Copilot can give you the shell code. And on the left, this is an example. Please help me to analyze the NGX performance bottleneck and give me some suggestion. That is the sentence you can input into Copilot. And then the Copilot will help you to list all of the possibility that you can do to do the performance tuning. So that is very helpful job. You can see after the job, we can get around 30% of the performance increase. And on the right side, is another very interesting idea. When we talking about AI, I think the most important part is we can use the language to talk with the machine and let the machine to do something. And of course, we can in openEuler we do a lot of tools. For example, we do ops tool, AI ops tool. The ops tool can help you to do the DevOps, to use AI to do DevOps. But can we use the language, the nature language, to talk with the system, to let the ops tool system can help me to do the DevOps? It's a very interesting idea. So on the right, you can see you can do the ops job. That can help you to link the EulerCopilot and the project of AOps. So you can use the language to talk with the Copilot. So, okay, I want to find if anything problem in the cluster in some time. The time is April 1st. In April 1st, maybe the cluster has some problem. You can say, okay, can you give me the clue of some information why it happened, what happened to the cluster system. And then you can see the system, the EulerCopilot gave the command to the AOps system, and AOps system will give you a lot of analyzed system. For example, some abnormal event 1, abnormal event 2 to tell you what happens in your cluster. So if we have a tool, we call it EulerCopilot, you can extend your, the idea. If EulerCopilot can resolve the nature language and make to link with different tools, so in theory, we can use openEuler, EulerCopilot to link different components of operating system. And then maybe in the next decades, the interface between the human being and operating system will change a lot. You don't need to know a lot of detailed shell command to remember all of the things. You may use the natural language to talk with the operating system and let the operating system to do what you want. So that is, I think, the big change for operating system. Okay, so that is one direction. We use AI to change the behavior operating system. And another direction is to use operating system to accelerate AI computing. For example, we know training is a lot of a big, heavy computing system, and the process is very long. We consume a lot of resources. The operating system can help the process to be faster and more energy saving. So that is very interesting topic. Here we also do some innovation or some testing job. Here we have a GMEM system. GMEM system is a memory hierarchy memory unified system, which can build on top of the main memory and the memory in the GPU or TPU or other XPU, and make all of the memory to be a memory pool, and then reduce the movement between the different memory part. And then after that, we can see we can accelerate the training process of AI around 40%. So that's very interesting technology. Okay, beyond the three labels, the all scenario, the diversified computing, and the AI, we also have a lot of new innovation. For example, I mentioned in the all scenario, we have the embedded system. Also, openEuler has a embedded version. And on top of the embedded, we move a lot of the infrastructure, framework, key features, and build the ecosystem for embedded. But the time is limited. I don't extend the detail. But just remember, openEuler embedded system has a lot of industry, has been used in a lot of industry companies, and we have a lot of details. And if I remember correctly, tomorrow we have a specific session to talking about openEuler embedded, and Dr. Ren will give more details. Okay, here is the growth of openEuler. openEuler is start from 2020, and it's donated to Open Atom Foundation in 2021. So until now, openEuler is a foundation project. Anyone can get involved in the project. And in last year in China, we have around 37% market share. So that is where we worked with our partner to achieve this percentage, the market share. It's very big. This is the #1 in server and cloud environment. And very amazing, just in 4 years, we achieved so many big market share. Because I think maybe one feature, one possibility is the China market is also very young. A lot of people like to try new things. So I hope in Vietnam, it's also a very young country, a lot of young people. So we hope the young people can choose the new things, the young things, to achieve a lot of interesting results. Okay, besides a lot of those kind of technology, actually in openEuler, not only we have mentioned the 3 technical labels, we have developed around 500 new setup projects, which including the dev tools, security. For example, the security we have SecGear is a confidential computing framework, and the SecPivot is a security policy toolkit. And also we have multiple kernel architecture. We have basic service. The service we create a start word which can replace if you don't want to use the Kubernetes. QML is so complicated and so heavy, so we can use Stratword, which use the Rust to rewrite the virtualization layer. And also we have Euler. It's a lighter and faster container engine, runtime engine. And also we have the cloud native. We have Kubo, Argo, Rubik, and we have the embedded, the Mika system, and we have AI, the EulerCopilot and GMEM. So everything in openEuler, all of the 500 new projects are open source. Anyone can get it and get involved with it. Okay, so in next month, we will release the new RTS version, long-term support version 24.03. It's a very, very important version for the next 4 years and get involved a lot of company, Intel, AMD, and a lot of international company. We work together to make the release. And the new release will focus on the AI native and cloud native and hardware collaborative job. So if you want to get more details, you can go to the booth, and we have a lot of very detailed explanation. Okay, here we go. How to engage? It's very easy. You can go to the Twitter. You can go to the website to contact with us, approach us. So I hope in Vietnam, the new generation developer can try our new project, and we work together to achieve, maybe to change something, especially to change the old, maybe traditional operating system. Okay, thank you.